Okay, so hi guys, good evening. So today is the day one for CCNA batch, and 𝐊𝐤𝐬𝐬, just wait for another 2 minutes and then you'll continue, okay? Because I think there are 35 people who already enrolled. So let's wait for other, and if in case they are not joining, within 2 minutes you can continue, okay?
Sure. Okay, thank you. Hello everyone, good evening. Am I audible to all of you?
Yes, ma'am.
Okay. So,
Good evening.
yeah, very
Good
good evening. Good evening. So this batch is going to be the first class. We are going to start the CCNA batch from today only. So before we start, we can just discuss few basic points. The reason is why do we need CCNA? So there are a couple of things that can be helpful for anyone who wants to go for CCNA. So maybe you are into the career change. Second thing is, which is mostly important, CCNA is never ever meant for the computer science background people only. So you are very well qualified to come for your passion if you have networking as your domain of expertise. Second thing is, after doing this CCNA, you will be having multiple options to go ahead. For example, you can move towards cybersecurity. So there is one company, it is called this Palo Alto is there, Cisco is there, FortiGate is there. So you have multiple options. You can go towards the cybersecurity, Palo Alto network team also, ASA firewalls and all. It depends. So now understanding of this CCNA is needed because of multiple reasons. So let's just set up our base first. I'm going to share my screen. Just respond me if it is visible to all of you. Okay.
Yeah, it's visible.
All right. Thank you so much. So, and by the way, I'll read.
Hey Shagun, sorry to interrupt you. Guys, can everyone please mute their phone apart from Shagun because it's creating a lot of disturbance.
Yeah. Okay. So thanks everyone. And yeah, now the main part is when you learn CCNA, we will learn a lot of things. So it might be, let's say, first of all, you would understand what itself a network is. I mean, how this internet is working for you. Right now, we know everything. Like, okay, when we try to open, let's say, Cisco.com, we know like how it is working. But once you are CCNA, at least not certified even, at least CCNA study, sort of a graduate would I would say. So you know the function behind how this is website is coming to you. So that is the main point you have to understand. So in computer networks word, how many terms of network devices you can name them? So maybe rectangle box we can denote firewall. This circular we can denote for router. What are the other ones that you know? Maybe you can go for switch, or let me denote the switch like this. These are the major ones actually. So rest of them, yeah, we can have the variety or we have to the variants of these only. So for example, if this is firewall, we call it next generation firewall or non-next generation firewall. If it is a router, so we do have multiple series of router also, higher end series, then we do have low end series router, and we do have different vendors. So we do have Cisco routers also. So this is your switch. Again, we do have a lot of variants in switches also. You can have layer 2, layer 3, multi-layer switch also. So this is what your overall idea is. So when you are into the student of computer networks, you are not just like learning how the theoretical stuff will be working. You will also be learning if you have this firewall or if you have this router with you. And obviously, one of the most prominent thing that we have ignored, that is your laptop or your PC. So if I'll give you these 4 type of devices, how you would connect them so that you can have internet on your PC. So let's assume you are given with each and every single facility that can avail that internet facility for you, and but it is up to you how you make the connection. So one connection is you can connect your laptop with your router, and further your router is connecting to the internet world. So this is something that is possible. Again, another option is you can connect this thing with your firewall also. And your firewall is also connecting with the ISP. So make sure it is not connecting with router. It is like this. So third option is like this, and it is connecting to a router, or with or without router, it can go towards ISP. So these are the various options. So before understanding, okay, there will be IPs, there will be routing. So routing means your packet is going from here, this guy, from PC towards internet. So if you are opening this website as cisco.com, so your PC is generating the request like, okay, give me the web pages of cisco.com, and these web pages are coming back to you. So why they are coming? Because they know which way you have to go. So in the world of internet, this is called routing. So now let's take some examples and let's identify the part of our curriculum. First one, we will be understanding how this internet works. Okay, so internet, we can say like working. So we call it in normally OSI model, TCP IP model. So second thing is, what is this IP addressing is? This is the most important part. Third one is, under the IP address, you can mention some sort of subnetting. Okay, so you do have some sort of subnetting also, supernetting also. We will be learning what kind of various subnets or various IP addressing you can have. Then definitely routing, then switching, all the configurations that you will be doing on a router, it is called routing. Fine. So we can say whatever the purpose router is made up of, that is called routing. Similarly, it is switching. Switching is basically dedicated to a switch. However, the data is being processed by the switch, that is the process of called switching. So now, what is the meaning or what is the significance of having different network devices? Why can't be a router work like a switch, and why do we have to have a switch? So there will be some special rules, protocols. I mean, there are some ideology behind why router is the working as router and switch is not being called as router all the time. When you have layer 2, layer 3, what is this layer 2 and layer 3? So that is all about you have to learn. So by end of this course, you can assume yourself you will be very well working with. If you are typing like today, you are typing https://www.google.com. So it will not be just a website for you. You will be able to call it this is a web traffic. So you would be able to identify you as a beginner or as now the learner. Okay. And now when you are sending, what is this HTTPS thing? Or what is the normal HTTP thing? Why do we have all this? This is also we have to learn in your CCNA. Second thing is, if somebody nowadays, you all have seen like, let's say I'm working in a company and I'm working from home. So, but I do have some technical issues in my laptop, but somebody sitting in my office in a different city, they are getting the access of my PC and they are fixing my problem. So that is called remote access. Okay, so how this is possible? That is again the part of your own curriculum. So that is the CCNA stuff. In technical terms, we called it telnet or remote access simply. So we do have multiple type of telnet also. Then now let's say these are some basic technical points that you will be learning. And now talk about in terms of practical use of whatever you will be learning. Now let's say I have a network. So let's assume this is my PC and I have a router. I know you can be confused, like why do I need to have a router only? Why can't I have a switch over here? Yes, these are the common questions we will be answering. Yes, Vaibhav, just allow me to finish this topic. I'll come back to your questions. Everyone who has some any question, just hold on. Then I'll be coming back to those questions because we have number of participants are higher over here. So otherwise we will break the flow in between. Okay. So let's say this is whatever your router is. This is my laptop where I'm at home working. And let's say this is my Wi-Fi router is. So you can assume it is your Wi-Fi. And every Wi-Fi connection has one router at our home. So that is that router. You can imagine. And further, that router is basically linking towards one ISP. So when we say ISP, what is so special about ISP? So ISP is basically that is taking forward your request of having internet on your device. So that means it is helping you to give the internet on your laptop. So because of ISP only, you are able to see now this session on Zoom. If there is no ISP thing call in the world, we cannot never ever connect with each other. When we say internet, it is like various all the ISPs connecting together. So it is like a connection or interconnection of all the ISPs together. So that means now if I have multiple ISPs connecting together, definitely it can be called as a internet. It is not, it can be called. It is called as an internet only because ISP means my ISP is talking to some other ISP. That ISP is talking to some other ISP. All together, they are forming one sort of interconnection. And because of that internet connection only, we are able to route our any traffic from client to server side. So this is what the main point is. When we talk about internet, that means we are talking about all the ISPs. Now, how this ISP is connected with this OSI and addressing what we have to do with this OSI. Why we need to configure this OSI? I mean, cover this OSI. So these are the set of rules, like we are saying, like how your packet, how your traffic will be processed. So let's say you all are here. Now you tell me when you open this website, www.google.com. What is this google.com? Anyone from website development? What is this google.com?
It's a search engine. Search engine.
Yeah, it is a search engine. Very good. But how this search engine is working? It is a website, okay? So for example,
It's a website, but behind the website there is IP address. It's called
Yeah.
vice versa.
yeah. So anything that is starting with www, it is nothing but it is a website only, okay? So let's say
It's
any,
a domain we can consider it.
okay. Vaibhav, you have to ask your question now because otherwise I'll completely forget. Yeah, please tell me what was your question.
Continue, please.
Vaibhav, am I audible to you?
Yeah, you are audible. Continue, please.
Right, okay. Okay, so any website, let's say any website, it is nothing but it is a systematic arrangement of many web pages. Let's say I have to design a website. What I will do, there is a language, it is called HTML. Okay, so let's say I use one language, it is called HTML, hypertext markup language. Any website who is working nowadays that was fundamentally based on HTML. Nowadays, Python has overcome everything. So most of the things we do have converged into Python. So this HTML, it is like we will create some. You can remember, like you can correlate it with a notebook. In a notebook, you have multiple pages, okay? But these pages are bundled together. So, but individually, these are called pages only. So, if you have a notebook, that means you have a bundle of pages. Similarly, if you have a single page, that will be called as a web page. Web page. But if you collect all those web pages together and you give them ordering, like, okay, when I have to create my website, when the user will open www.mysite.com, for example, mysite.com. So when the user will enter this website and hit enter after typing this in the Google Chrome, first of all, they must see the home page of my website. The very first page that we type any address on the Google Chrome, and the first one that we see as the output, it is called the home page of a particular website. So similarly, if you will be typing google.com, first thing that you can see on your screen, it will be nothing but your home page of the Google only. Similarly, we do have home pages of various websites. Okay, so this home page will be the introductory page. Then you will be having some further pages. Let's say you want to buy some product from, you are going through a website that is selling some product. So you are going to buy something, then you will be selecting it, then you will be paying that for also. So now let's say these all are nothing but different web pages who are coming as per your request. So for example, if you are selecting the payment gateway, this is the web page who is coming over here. If you are selecting as buy option, if you are filterizing through some filters, it is coming under the buy option, buy web page. But all of these pages are connected to each other through this HTML code. So depending upon the user access, for example, whatever the user is clicking over there, your website is working accordingly. So that is the fundamental behind what is a web traffic, a website. In computer networks, we being network engineers or we being the cybersecurity engineers, we don't call it a website and all, because we always deal with what kind of traffic is being generated. For example, if this is my LAN site, if I do have my LAN site over here, and I do have my router over here, and after that I'm going towards internet somewhere here. So that is like what my, how that web traffic I'm working, that is what my interest, area of interest. Being a network engineer, you are working everything on the basis of traffic. Even you are simply trying to ping only. You are pinging somebody. Pinging means to checking the connectivity, whether you are able to connect with the device over the internet over here or inside your own LAN site. So maybe you are only over here. So let's say this is all the users that will be sharing this link together. So it is like the part of the same family. So these all are the same family members. Okay. So this is the exit door for all of you who are belonging to this family, and this will be the entry and exit point. So this is called in computer networks, we call it a gateway. Okay, so gateway is nothing. When your LAN side user, we call it local area network. All the people, all the machines who are connecting with each other and who are sharing the network address, these are called LAN. So we do have some ways how we connect these machines with each other. Now let's say I have some number of machines with me. So let's say I have a small company where 20 people are working. So those 20 people I have divided into 5 groups. So let's say this is department IT. So this is my IT department. Now I will group them all together into one group. Okay, so this is called my IT department. Same thing, you can imagine one or two department more. So what I'll do, how will I process my internet? How will I design my internet architecture over here? I will place one router. A router is a device that you have to have if you want to get internet, because without router there will be no way that your data or your packets, we normally say, so whatever the traffic you are generating from here, it cannot be exited from your side, and hence it can never ever be reachable to internet. So if you want to have internet, you must have one router with you. So router is a must thing for you. Without router you cannot go for internet. Without switch, yes, you can. But why we need switch? Now assume this is router. Always, whenever you will be having any network device, there will be a connection point also. So these connection points are nothing. For example, we buy a new iPhone, new mobile phone. So this new mobile phone will be wherever you will be putting the charger. We call it a connection point, right? Similarly, if you do have this layer 3, normally networking device, for example, we have router, its name is router 1. So if you have this router, that means you have to connect it. But that is the main meaningful point over here. Then you have to understand how you will connect, like if this router will be the gateway. Now we should be getting into used to of this terminology. So this router is the gateway for this whole LAN. So this is the LAN. It is called local area network. Local area network means the piece of, the collection of all the devices who are sharing the same network. So here comes a new term. It is called network. Network is basically not equal to internet. Internet, as I already told you, internet is actually ISP. ISP means all the people who are in the internet, you can browse anything and they will give you the output. For example, if you are opening www.google.com, it is browsable. This is a website. All of the world, they can open to use it. Yahoo.com, everything. So such kind of special websites, we normally call it URL, Universal Resource Locator. So these kind of URLs are browsable no matter which corner of the world you are sitting. They must be giving you the giving you the output. So condition is you should be having internet connection. Okay. So now let's say we want to form one topology. Normally we call these networking kind of diagram, we call it topology. Now we want to form one topology and we want to connect all of them together with each other. So first of all, let's say this is a router. On a router, we have only one interface to connect. So that means either we can connect this PC or that PC, that, but we have multiple PC and a router is expensive also. We cannot have, it is like sometimes it can go up to 2 lakh, 3 lakh, 4 lakh, 10 lakh, depends upon the functionality. So even if you are using very cost effective router, still it will be ending at not less than 2 lakhs. So that does not make any sense. You are buying a new router for every new device in your LAN site. So that means now here comes the use of a switch. So switch is a device. We can say switch is a network device that will do what? It will be working like in our normal homes. We do have extension. Okay. So for example, if we don't have number of sockets available, like let's say I have two phones, I have one laptop and I have one speaker, I do have one power bank, but I have only one socket. So in that case, what will I do? I will go for one extension. So that is the fundamental behind the switch. Switch is nothing but it will behave like an extension only. So what you will do, you will connect all these PCs, all these devices with the switch. And now you will connect this switch further towards your router. This is possible and this is a valid solution to your problem also. Now, how many connections you can create over a switch? What do you think, like how many devices we can connect on the switch? So this is a standardized decision. So either a switch can be 24 port. 24 port means again 24 interfaces. So if a 24 port switch we do have, it would look like this. So let's say I have 24 port switch, 12, 1 to 12 ports will be here, 13 to 24 will be here. Assume these all are the interfaces only. So these all are the interfaces all the way. And now if you will be connecting 24 machines at a time, you can connect it. What are the other things that you can do? So for example, on a in a company, I have different departments. Now I say I do have two departments. So far we have discussed, we have only one thing, one LAN. Now we can extend our talk. We have two departments now. So first, my department IT and another one department is HR. So HR is actually on the second floor, or we can say first floor, and this guy is on the second floor. So definitely whatever the cabling you will be in switches and or routers, same cabling it will not cross the length, just like our mobile laptop, mobile chargers, right? Or laptop chargers. So same length of these cables can be there. Whatever cables means, now I'm talking about the cables. Whatever the cables you will be using to connect with your switch to your PC. So if you are connecting one PC over here, so that means that PC should be at a commutable distance to your switch. Either you have to have a very long LAN wire. We call it UTP cable, unshielded twisted pair. We do have different variety in that. So every UTP cable, UTP means unshielded twisted pair. These UTP cables, they come with different bandwidth and speed. So for example, 10 base 2. Then we do have 100 base 2, something like this. They will be giving some sort of speed stuff. So these are the 10 megabits per second, 100 megabits per second. So this is like, I'm not too sure like what will be, because now they might be out of the scene in the market also. But when we used to study the CCNA and all, this was the base to understand like how you would identify these cables and all. So now if you are understanding like, okay, we need cables also. So if you have to set up your own internet, I mean the network connection in your own company, you have to have some network devices, you have to have the cables, and you have to know like how to connect them together also. So let's say you have connected all those 24 PCs over here. So over here I have 24 PC. So everything is connected now. Now one of the switch port you have to remain as open for your uh, router, where you will be connecting it with the router. This is one option. Now, what about our second floor? What happened to that? Let's assume 12 PCs. I can behave like this. 12 PCs are belonging to my HR department, and remaining 12 are the part of my IT team. So if I have to reach IT team, then I have some different arrangement. What I'll be doing, because again there is a distance that matters a lot. That matters a lot. Now I can connect one more switch, right? So I can have one more switch. I can take a small switch, maybe 12 port switch. So I can go for a very small switch, and then I can connect the further remaining devices over here. Rest of the 12 I can connect over here. So you can assume like you can reach to this second floor by just extending your connection. But now in this case, it will be a little higher on your cost side because you have to buy two switches, and switches also not very cost effective thing. It will be a bit higher side, but less than router. So switch and router both are needed if you have to form a network topology. We call it topology. So just like when we construct our house, we go to the architect. We ask them like we want this kind of house, 2 floor, 3 floor duplex. We want these many bedrooms and drawing room, kitchen area. This one. We just tell them, and they will give you some sort of blueprint. Like this is the way how you will be actually your house will be looking. Nowadays they will be giving you some 5D, 3D type of view also on the print only. Similar thing when you are a network engineer, you should see everything just like you are the architect of that network. There are some positions they are called network architect also, in fact. So now let's assume you are designing somebody's network. So definitely you will give them one diagram. So you will say here you will place two switches. One will be on the first floor, another one will be on the second floor. Here you will be connecting your uh, 12 PCs over here, and now I'm going to connect make everything like this. So this is your HR team, and this is going to be your IT team. So you can connect all the PCs, and the common switch can be the connection point for them. And this is your IT. And then after that, you have to connect these both with the router. Now you have again more options. We are self-assuming now. Further, there is nothing but www, that is internet, worldwide thing. One option is like this. You can use the two interfaces of the router, and you can connect these two switches with the router. Or other option you can have, you can also connect these two switches with each other, and the final connection can go to the router. Okay, so this is what may be the case is. What do you think? Like how many connections you can have in this idea?
A lot of devices. By switches, we can join many switches by this idea. And as per the speed of the router and internet.
Yeah. So
No,
maybe
we need we are going to use here managed switch or unmanaged, because it depends upon scenario, what kind of scenario we will go through.
This is layer to actually this is layer to search. We need a virtual connection. I mean VLAN.
Okay, sir, layer 2 switch or layer 2 always, but now there in market there are layer 3 switch, but layer 2 switch there is managed and unmanaged switch, right?
Yeah, this is unmanaged switch. We need a layer 3 switch.
If there is unmanaged switch, how you can create the VLAN? So it's a little bit.
We need a layer 3 switch. We can connect to trunk port to connect one link to router. That is
if we
impossible.
go-
Okay. We cannot go too technical in this class because there are people who are in the very beginning stage. They will be scared of like whatever you are talking. What is this VLAN?
Exactly.
Okay. So, okay, I'm trying to keep everything very, very simple in the word so that you can fit these devices into your mind. Like you can create a visualization like, okay, this kind of need or requirement would be fulfilled by a switch. If I have this kind of requirement, then I need a router. If I have some other choice, like how can make the rearrangements or arrangements with each other. So this is what you have. All you don't need to, be in a hurry. Just go slow, understand, get absorbed these all things. We will be very good. Don't worry. It's very, very basic level code. We will be good in this. Don't worry. So now let's say we are talking about switch, we are talking about router, but now how the switch would come to know how I have to behave with other switch. And now how this switch will come to know I have to behave with the other type of device itself, which is a router. And how the switch will come to know how I have to behave, because you can assume this round thing is nothing but a whole small collection of your devices. Only
Devices.
devices means PC, laptops. So it is like you are giving some sort of sense to your devices. Similarly, your PC, because ultimate our access is not, we are the internet user. We have never taken any access to switch. We have never gone to any router. We use either our mobile, tablets, iPads, or maybe we just go for laptops. We don't know what is going behind the scenes, right? So now, how many devices we can now collect so far? Names, we can have PC, we can have tablet, we can have mobile, or we can have your laptop. These are the basic ones. Second thing is, now we know something is called switch. Now we know something is called a router. And fourth thing is, we know there will be wires to connect them. So these are the minimum requirements that without going through these details, we cannot jump towards the highly technical things, right? So first of all, these are the base. Okay, let's say this is my PC. Now let's come back to the point. Let's take one more topology. This is my PC. Let's assume all of you, now you will be easy to understand because all of us, most of us, we are connecting through the Wi-Fi only. So we are connecting to a router. This router is taking us towards the internet like this. And now whatever you are doing, that is being passed through this router, and you are fetching the results from internet, and they are again coming back throughout this router only. So what will be the idea behind how this router will come to know when, if let's say you never know how many routers are there, right? There will be one more router, there will be one more router. You never know how many routers are crossing. You are crossing on the way to your destination. Right? So we know like, okay, there is internet, but internet is again what I told you, internet nothing, but it is a collection of ISPs. These are called ISPs. So any router that can be the ISP. Whatever the router you can see at your home right now, that is your ISP. Further, that ISP is connecting to some other router, that is again ISP. So these ISPs are connecting to each other to form a www, World Wide Web. So, okay, now let's see how this PC would know. Like I have this internet thing is when you go to Chrome and you type this HTTPS www.google.com. This is a very basic thing. Who is responsible to tell your PC like this is now something related to internet? This guy is trying to go to internet. Who will tell your PC? PC automatically, it is a machine only, right? Somebody has programmed it. So who is telling your PC or laptop like, okay, you have to go to internet now? How this the process will be being done, that is a different job. But who is telling your PC this is the first place? That is your operating system.
Operating system, yeah.
Okay, so under your operating system, you have some networking operating system also. We call it net operating system. So in operating system, every single thing is mentioned. Like if something, any request is coming like this, and you are accessing Google Chrome also, everything, how you will be processing further, it is already programmed. So this is operating system. So this is actually guiding your PC. So do you think it will be similar in your network devices also, like switch, router, firewall? So answer is a very big yes. Every network device, there is one operating system also. So the common thing between your device and your networking devices, that they all will be working on the basis of operating system only. So this operating system will tell them how to talk with each other, how to behave with each other, how this router will be behaving with this router. So for example, there is a
iOS would be there, ma'am, right? On router iOS.
yes,
iOS different
yes,
routers,
yes,
yes.
yes. So it is like the name of these operating system, there we call it iOS, and on our laptops or on PCs we call normally operating system. So these are called iOS. We will go into iOS, but don't worry. So these are some sort of heavy terms. So anyway, thank you. And let's say now your router, it is like your operating system is the guide. Wherever you are going, it is guided by your operating system, how you have to behave. Now, here comes the role of your OSI and TCP IP. So normally people say OSI model and TCP IP model, these are the two theoretical topics. No, they are not the theoretical topics. This is what you have programmed over here, operating system of your PC and operating system of your router. Everything is programmed. When it comes to internet part or networking part, everything is comes according to the OSI layer, we call it, or we simply call it OSI protocols or OSI rules. So what is OSI? OSI, it is called Open System Interconnect. So this is a model. Okay. So model means it is the blueprint, how this device will be working, how this device will be working, and all together, or if they will be coupled together, how they will together will be working. So it is very powerful model. So it is based upon some sort of layered architecture. Layered architecture means what? So that means if I have a company and I have a model that I called layered architecture, I'm following one layered architecture in my company. So that means I do have some sort of priorities. So let's say this is my top layer, this is my middle layer, and this is my bottom layer. So that means there are some managerial person who are sitting over here. There are some person who can deal with both the managerial and the actual workforce. And this is my workforce actually. So this is called a layered architecture. And also sometimes we can refer it the hierarchical also. But layered means one layer another. You can take one example of onion. Onion is what? Onion is having too many layers, right? You just simply start cutting the onion. It is full of layers, one layer after another, one layer after another. Same thing. OSI is nothing but that kind of layered architecture. So you have to imagine that kind of thing. So because onion is a very basic thing, everyone must have seen what is an onion. No need to explain at all. So what is the layered architecture? What is the fundamental of having layers? Why do we, okay, talking about the onion, why we have onions, we don't know. We never researched, okay? We are not dietitian and all, but see, there is a fundamental benefit. If you have layered architecture, let's say, let me draw some sort of layer for you. I have one outer layer, then I have one inner layer, and then further I have some inner layer. So this kind of layered architecture, it is number one, if anyone is trying to harm you, it can only harm up to this if they have the knowledge of the outer layer. Still your inner layers are safe. It is like skin. Our skin is also layered wise, right? Layer wise layer. If your skin is getting damaged through your sun and all, So it is like inner layers will also be getting affected, but not immediately, not at the same time. But it is your outer layer who will be getting affected first. Second is, then if this is affected, then it can also lead up to here, but it will take some time. Again, it will take some time. So when you have a layered architecture, you can actually break your system's security. You can more strengthen it. Second thing is, you can take the privacy. There is a lot of privacy. No matter you are, anyone has managed to get the access over here, but nobody would know what is actually happening at the core. This is important. So that is also another benefit of having a layered architecture. Second thing is, whatever, let's say somebody is trying to get over here, and this one will be assigned with the outer layer will be having its own job responsibility. Whatever these managerial person are doing, they are parallelly doing. Whatever the middle, this priority people are doing, they are doing parallelly. So overall, my company is running. So every day, whatever the job is assigned to what layer employee, they are doing very well on that. Similarly, your OSI, we have 7 layers. So now we are getting into the business actually. So OSI, we do have OSI model. We have 7-layer architecture. Okay, so we do have 7-layer architecture. The very first layer, we always start talking about the first layer, that is called physical layer. Second layer is called data link layer. Third one is called your, oops, I'm sorry, network layer. Fourth one is transport layer. Fifth one is session layer. Sixth one is presentation layer. Now seventh one is called your application layer. So these are the 7 layers, but we always, the top layer, it is like a conventional or legacy way of typing these all 7 layers. So we never call it this is the first layer, and you do not never ever train your brain like application is the first layer. Not at all. It is the 7th layer. There is a very valid reason behind it. Always.
But ma'am, it depends on the receiver side, sender side. Which one is the first layer or 7th layer?
No, layer number will not at all be changed. They will be again same only, but the way you are writing, that might change. For example, if you are typing over here, for example, if I'm typing 1 physical layer, that is a different thing. But if you are typing like this, application is coming on the top, it should be numbered at 7 only. This is the rule number 1 of computer network. Okay. So,
but
first,
is it not correct that when you are receiving at that time it is physical, and when you are sending the packet or flow, it is application layer first of all?
okay, I'll tell you. We clarify that doubt also. This is what I'm going to explain only. Right.
Okay.
Model. Now they combine OSI and TCP model and combined, and they are agreed to have a 5 layers.
That is TCP/IP, yeah. Yeah. This is the receiver. Okay, this is receiver side. So again, how sender and receiver are connecting to each other? Let's say they are connecting through this www. Now I'm not going to draw any other device. Directly I'm going to draw this internet. So they are connected through, this is my sender, and I'm handing over my data to whatever internet is. Now they are connected with each other. This is sender and this is receiver. So now how I will generate the traffic? Definitely I need mobile at least. We want to see Insta, we want to use WhatsApp, anything. They are useless without internet. So let's say I'm trying to WhatsApp anything. Okay, I'm trying to open WhatsApp and then I'm typing hi to one of my friends. So number one, there is a commonsensical rule also. If I'm sending hi to her, she should receive hi on her WhatsApp only, right? It is not like I'm sending hi to her on WhatsApp and she is receiving hi on her Insta, right? That can be a technical glitch. That is not at all a very strange thing. It happens sometimes. These kind of things would happen. But how WhatsApp is generating the traffic from the sender side and how the receiver side WhatsApp is getting activated, because on her mobile maybe Insta is also there, WhatsApp is also there, but how it is identifying on WhatsApp only? There will be something very, very strong methodology, right? Otherwise, we are gone from here only. Because if two person are talking to each other, they are not changing their device to change the application also. We don't have multiple devices, like for WhatsApp, I'm using mobile number 1. For Insta, I'm using mobile number 2. Everything is on my single device only. But what is the logic behind, like these applications are being identified very correctly, like, okay, if something is being approached on WhatsApp, it should be received or it should be meant for the WhatsApp only. So this is called your layer 7 duty. This is your application. Application is the layer that is responsible for the user interaction. If I'm using any type of application that I'm actually using, I'm right now we all are on Zoom. This is layer 7 thing, because we are interacting with the internet through some sort of application. What is Google Chrome? Whatever the web traffic you are generating, layer 7. Whatever you are trying to do on WhatsApp, whatever Insta, Facebook, every single thing, there you want to achieve something, and that is, only achievable through internet. That is layer 7. Can I have any other example of layer 7? What you can think all of?
Websites.
Websites, yes, layer 7. That's
Web
what I
browser.
already mentioned, like Google Chrome,
Web browser.
Firefox, yeah, web browser. What else we can have on internet? Whatever you can use on internet, that is,
All application would be there, WhatsApp, Insta, Zoom, how we are interacting right now.
yes,
It is also on the same application layer, right?
yes,
First,
yes.
yeah.
So you have, let me okay, I'll dictate few applications. You all just finalize whether they belong to layer 7 or not. Okay, let's assume
Okay.
MS Word. What about this?
No.
No.
This is layer 6, not 7. Presentation.
Okay,
I think
okay.
it's
Okay,
presentation.
don't go to layer 6 right now. It's okay. Yes or no? It's a Microsoft Word directly is not interacting with internet until and unless you are not attaching that file, right? It is not a prerequisite for the internet. So it is a no. We are not into it. MS Word, we are not into it. And what about your Google Maps?
Yes.
It is, because Google Maps is based upon internet only. What about Google Meet?
Yes.
Yes.
Definitely.
Again, what about your calendar?
No.
No.
Yes. Sorry.
If it is Google Calendar,
It is scheduled.
if it is Google Calendar, again it is a yes, because Google Calendar means it will tell you all the calendar and what is happening in the worldwide also. Also, somebody has invited you for something. For example, in corporate world, we do have some sort of meetings. So they just block our calendar accordingly. Automatically, that meeting will be popped up on exactly on the same day. Yes, Google Calendar. What about Siri?
Yes.
Yes.
Definitely yes.
What about
Because
Google
it is showing by net only.
Yes, Siri is it is Siri is the one that will be working on the AI based engine. So it is definitely internet oriented only. Yeah. Google Assistant
Also.
again.
Also assistant.
And what are the other things that you can think of? Spotify?
Spotify, live streaming applications, gaming applications.
And if, for example, if you are on Spotify, you want to listen some music without internet, only some limited music can be possible that you have already downloaded. Sometime even that is not possible. So Spotify again, it is like layer 7. What about Snapchat?
Yes, definitely, ma'am. All the application which is connected with the internet, that will be comes with the application layer
So
from my
that
side.
is something that now we have to understand. Okay. So now the way, let's say this is our sender and this is our receiver side. Receiver side may be a server also, or maybe it is again a normal PC or computer also. Okay, hold on. Let me just remove this. Just looking like messy. So maybe your receiver may be a server, or maybe your receiver might be your friend only, right? It is not like always a server only. So, but the both parties are talking in that case. So now we have to talk about basic, like you have to stick with your basics now. So now you are just chatting with your friend on WhatsApp. Let's say I'm chatting with my friend. She's also replying me back on my messages. She is not server, even I'm not server, but how we are talking? We are talking through server. So these requests are going like this. Because why WhatsApp will be giving you services for no reason? So whatever you are sending, hi, hello, how are you? That is going through your WhatsApp server. Now, where is this WhatsApp server is? That website, this WhatsApp server is somewhere in the globe that you don't even know. How you will come to know where is WhatsApp? So there are,
Probably on the headquarters, I guess.
so it will be somewhere if you will be getting into the network, if you will be capturing your packet. So you want to see like what exactly, where the hell these are going. So these kind of things are very possible if you are, have you even, any one of you have tried web-based application? For example, you can connect Zoom as an application also. You can install, download it, and you can connect to Zoom through the web also. So you don't need to have the Zoom as an application with you. So if you are on the web, that means you are going to first of all Google Chrome. Then you are typing zoom.us or whatever, and then you are on the web only. It is asking enter the meeting ID and code, and you don't need to have any application. You are simply joining from the web. So that is a web-based, utilization of your traffic. So now we have this WhatsApp as the application. You can access that app WhatsApp as a web-based application also. I mean web-based traffic also. So in that case, whatever you will be doing, we do have some strong tools. One of them tools is called Wireshark. So this Wireshark is very capable. Whatever a single, even if you are breathing out from your system, who is on the internet, whatever your system is doing, wherever it is looking at, and whosoever is looking at your system also, it is that capable. It will capture everything, whatever your system is doing. Sometime, let's say I'm not doing right now. A few minutes back, I was trying to open google.com. Right now, I'm not on google.com. I'm on the Zoom right now. But still there are some packets continuously they are traveling. Even I'm not generating any traffic, but still there is a data that is going on between the Google server and between my Google Chrome's Google, that website that still is open. So that can be captured through Wireshark. It is a tool. What are the various other tools that we will be coming across? Number one, Wireshark. Number two is Putty. So that is your Putty we need. It is again, you don't need to install it, or sometime it is in come up with as it is in your operating system only, or sometime you can install it also. So Putty is a tool that will be allowing you to take the remote access. So I'm talking about the tools now. It is for the remote access. So meanwhile, whatever the tools I will be coming across, I'll be keep on noting down over here. So coming back to the point, today we will be going through the overview, not the technicality, so many things. So now let's say I do have some sort of web application. I have sent hi. So that means now,
Ma'am, before that, before you start, I want to ask one question. What about the devices? Like repeater, modem, and switches, and on these, on which softwares operating systems are installed? Will they also will be comes in this side application layer?
No. Devices, it will depend. For example, if you are using router, you are here only, network side.
Okay.
If you are using a simple plug cable, your UTP cable that I was saying, na, like this is a LAN cable, that is here. If you are using your switch, that is here. So these are the layers.
Even there's a operating system on that device.
Yeah, everything. That is, these are the layers: layer 2, layer 3, layer 1, and layer 2. These are 3 layers. These are dedicated to your physical and hardware devices and connections only. But
And
if
servers.
yes, everything. If it is a server, then it will come under your network only.
Okay.
Okay. So now let's say you do have WhatsApp. We identified it is a layer 7. Yes, very well. What about presentation? Presentation means you sent hi to your friend, right? So you sent hi. So that means hi must be received by your friend only. It is not like something else is some other, language is being typed over there. So that will take care of what are you sending. So it is content now. What is the content? So that is a presentation. Content might be your clear text. Clear text means hi. You did not encrypt your data. You are not using any encryption. You are not using any special characters. You're simply saying hi. So it is readable, right? It is readable from me also, from you also, from anywhere in the world. People, they would be, it's plain English. Now, if I'm typing something like this, it is not readable. You cannot make any sense out of it. It is called encryption. So if it is encrypted data, it should be meant to be received by the receiver in encryption manner only. If it is clear text data, then it should be appeared as the clear text data only. It is not this list would not be ended over here. Now let's say if I'm sending one song, let's say Akshay is on the other side of the Zoom. So I'm sending one song to Akshay, or I'm sending one tutorial to all of you. That means that is MP3. So that will be the file type. It is MP3. If I'm sending some sort of documents to all this batch, so that means these are .pdf or .doc, right? So whatever I'm sending, it should be received as it is to you. It should not be like, okay, I have sent one document and you are not able to open it, or you do not have the access to open it. So these file types are identified from your layer 6. It is like a content. Whatever you are doing, that is important over here. In application, whatever the content you are wrapping in to send somebody, and what is the medium you are using. So this is the content. You want to say hi, that is your content. But hi using what? Insta, WhatsApp, Snapchat, what? That is your layer 7 application. Okay. Yes, Ramesh.
Yeah, ma'am.
Hmm?
Yeah, ma'am. I have one question.
Hmm?
Ma'am, when will you complete this season?
In next 5 to 10 minutes, maybe next 5
Ma'am,
minutes.
finally, I will ask the one question, ma'am.
Yeah.
Okay, you can go ahead, ma'am, please.
No, please tell me what was your question.
Ma'am, my question is, ma'am, I am in India. Okay, 20 people are in the US. Okay.
Okay.
One people's getting a slowness issue.
Okay.
Okay, my side, I'll check the LAN connectivity, pinging, get trace route, everything. Okay, bandwidth, everything is fine. But still the user is getting slowness issue. What type of troubleshoot you are doing? What is the
Okay.
issue exactly? Because the rules is everything is correct in firewall.
Oh, you are asking the question from firewall. So
Yeah, no. Firewall rules is allow only. Then I check that pinging connectivity, everything pinging is fine only. No dropping issue. Bandwidth as well is very good only. But still the customer is facing slowness issue. What is
Okay,
that?
I will give only a few seconds to answer your question because this is like a very high level question in this batch. But yeah, still because
No,
I
ma'am,
used to
because if I
yeah.
go anywhere, the same question will be asking, ma'am. So that's what.
Okay, okay. So quick answer to your question is this is basically related to
No,
your
you can tell me. Please mute on someone. You can tell me like that only.
okay, okay. People who are not talking, please put yourself on mute. Baki, Ramesh, the answer to your question is it will be it will be depending upon multiple devices. So we need to have the topology first. We need to have the configuration. If it is your firewall, then you have to check, is it happening with a single user? It may be happening since what it the issue is happening.
20 people are getting a good only, but only one people's only getting slowness issue.
So it might be their it's a firewall side. You can check like whatever the packet or the traffic log.
Yeah, I checked that firewall as well. Everything and source to destination.
Okay, we have to withdraw. We have to withdraw this question. Actually, this will be too high for these.
If you give the correct answer, miss, I will join immediately. Now onwards, in networkings.
Yeah. So it will be.
Ma'am, if you don't know answer, means I will drop out this argument. I will drop out this session.
Yeah, sure. It's okay. It's okay. We actually this question.
Actually, you also don't know, right? You also don't know, right? This question.
Yes.
So I will leave this.
Sure.
No one is joining this session. Goodbye.
Okay. Bye. Fine. So anyway, so this is the content. Like whatever the content you are sending, that will be presentation layer job, right? So for example, we are sending any file. You are sending hi. You are sending any encryption, so that will be your content. So it will be taken care of your layer 6. So that is responsible for that. Now, what about your layer 5? That is your session layer. What will be the idea behind layer 5? Session means what? When we can correlate it with the real life.
We cannot send up data in a single unit, so that's where session layer comes in role.
Okay, let's assume now we go to bank to open our account. Okay, so when you enter into the bank, they will check your ID card and then they will, let's say they are giving you one token number. They will say, okay, you wait over there. Then you are starting to wait for something, like some staff member will be allotted to you, and accordingly you will be getting your bank account open. But is that token number is your bank account number? No, right? That is just the way how they handle number of people. So that is also traffic handling system only for them. So the session is, let's say, not bank account. Let's take the example of sending courier back, because that would make more sense over here. So you want to send something to your friend, maybe through courier. So now you are sitting at the courier office. They are asking like, okay, can you show your ID and all? So that is the first thing. In session layer, always it will happen who you are. So layer 5, that is the session layer. So that will be first of all taking care who you are and prove that. So you have to prove that. Second thing is, now you are going to say whom you want to contact. That also you have to prove. So that these are the kind of proofs now you have to have. Now let's say you are asking like, I have to send a book to my friend from city 1 to city 2, and now they are giving you some sort of document. First of all, they will check, do we have the service available in the destination city or not? Like in city 2, do they have the same office available or not? If it is yes, then they will check, okay, fine, you can go for it. So, but now until and unless your packet is still on the table of that employee, the staff member only, so they are still processing. So that means you are still engaged with somebody who is processing your data. So that is called a session. Session means now you are in the stage of connection establishment. So that connection establishment is being established, or you can say it is being there just for the purpose of sending something. So that is for not sending something, I would say for the data communication or transmission. Right? So that transmission, until and unless it is not being done, two devices in computer network also, they will maintain that session. So for example, if you are doing your bank transaction, that is the wonderful example. There will be the session established with your bank. I mean, the server. Sometime when you refresh that, it will say your session is already expired. So this is what the example of your session layer. So session layer would be identifying you up to what extent you should be allowed to consume the resources of the server wherever you are going to talk to. Fine. So that is called your session. Now transport. What do we mean by transport? What you can think of when I say we in India, we do have a transport department. What is the duty of the transport?
Transport is receive and acknowledge.
Yeah, so transport means whatever, no matter either you are going by air, you are going by road, or you are going by water, maybe sea or what. So you have to, the idea is you have some sort of transition in your mind. So that means you have data that will be sending from a source to destination. So there will be a source and there will be a destination. So whenever you are talking about a transport, that means you have a source also and you have a destination and you have something to transfer them. So in transport layer, you have to understand three things. One, that there is a source. Second thing is there is a destination. And the third thing is called you do have something to send. So you have items to send. Right? So that is what the ideology behind the transport layer. So you will be having two addresses and you will be having what you want to send. So transport layer will be actually taking care of now the actual show will start from the transport layer. So whatever you were trying to send, let's say the source was me. Destination was who? My friend. Right? So items like what? I wanted to send hi on WhatsApp. So this is what the items will be. So in OSI layer, these all things will be technically broken into the headers. These are called headers. When somebody is typing, when somebody is tabularizing this kind of information, or who is the source, who is the destination, what they want to send, these are called headers. And each layer, no matter which layer it is, layer 7, layer 6, layer 5, they sometimes together called as layer 7 only. So these three things called together as layer 7. So we call it layer 7 header. So over here, we normally name it. So this is called layer 7 header. This is called layer 4 header. And this is called layer 3 header. And now this will be layer 2 and layer 1 accordingly. So this is the, sender side. So now you have come to know the role of transport layer. What will be happening on network layer? So now you are saying the source. Source means now you are more concerned on transport layer. You are much more concerned upon WhatsApp, not you. So this is more concentrated thing. On network layer, this is the concentration main, like source IP and destination IP. On transport layer, it is asking, okay, what was the source application? So that is your WhatsApp, right? So let's say I will be using some port number. So if I'm generating a web-based traffic, so I'm trying to open https www.whatsapp.com, something like this. So now what will be the port number I will be using? I do have some port number to identify these things. So these are called transport layer, stuff. So we do have 443. So transport layer is very well qualified to understand, okay, how many port numbers and which of them are the standard one, which of them were the random one, everything. We do have the classifications. So this source IP means what was the IP of the PC. Let's say my PC IP was 10.001/26, let's say. Destination IP was 8.8.8. By the way, this is the Google's DNS IP. Let's say whatever the subnet mask they are using, we are not into it. So this is what the information will be of interest for your network layer. Source IP, destination IP. So this is called layer 3 header. Layer 3 means they will add this header. And in layer 4, they will add port number. Port number means, so if you are sending, let's say now how the packet would keep on expanding. Okay, let me complete layer 2 and layer 1 also. Layer 2 means MAC addressing. Everything will be MAC address on layer 2. Now, what is this MAC address? Wherever you are plugging your LAN cable, you are plugging into one NIC network interface card, where you are actually telling this is my LAN cable and I need that internet. So on every NIC, there is one permanent address that is called MAC address. So that will be your the address of the LAN card. You cannot change it. It will remain same all the rest of your life. So now what will be the idea behind having IP also? Because IP can easily identify you, who you are. Why we need to have MAC? Any idea?
Please ask again.
Can you repeat the question?
Yeah. Question is, IP address will identify you, who you are. And destination IP will be identifying you, like identifying to whom you want to approach. Then on top of that, what will be the use of MAC address? Why we need MAC?
It is the identity of the
MAC
device.
address is considered identification of a device. Without
Okay.
MAC address, buried address are the same. Without MAC and buried, any device cannot work. So LAN address is different. Gateway is different. Gateway means where we will, which place. That's gateway means from which place we will go. And
Okay,
data
fine,
will-
fine.
Entry and exit point.
Okay, fine. Now let me give you one more real life example. This MAC address, let's say I have 2 people. Okay. So I have some sort of, I'm not very rich kind of person, and I have only one IP. So at a time, either person 1 can use or person 2 can use. So let's say the IP that I'm using, that is 10.0.0.1. So let's say this person P1 that has used and it is gone. So now once it is gone, the same IP is allocated to person 2 also over here. So this person 2 is also using the same IP. Now let's say this person 1 was innocent and person 2 is doing some malicious activity on this PC. But if somebody would be identifying who will be the person, either person 1 or person 2, because IP will be the same one, how you would identify? So the idea is over here, IP can be allocated once it is in not use, so that we can use the proper and effective utilization of the IP addresses. One IP can be used by multiple persons or multiple devices, but condition is, if one is using at the time, that IP cannot be allocated to anyone else in the whole world. No matter how many devices are right now, even each of individual of us, I think we are carrying more than 4 gadgets with us. So look at the scale of the IP addressing, but one thing is particularly guaranteed, no 2 of the devices on the internet, they will be having the same IP. So the logic is over here. So to identify something like who is doing what and who I have to the server, like how server would identify you. It is not previously person whosoever is generating the traffic. It is the new one now. So that is, you have to have the MAC address. So it is like a device based MAC address. Without MAC, it will be a confusion from the internet point of view. Like, okay, this guy is also having 10.001. This guy is also having 10.001. But where I have to land? I have to land as per the MAC address now. So it is like a tiebreaker.
Exactly.
Okay.
It's just a client. We can consider it client identifier as well, right?
Yeah, it is a client identifier, you can say. So now because we have gone through the details of, it is not a technical discussion at all. Actually, I just don't want all of you to get into too much technical, because understanding first of all and getting those all dots together on our own understanding, which is very much for going through the next technical discussion. So whatever is going on, application, presentation, session, transport, network, data link, and physical link is nothing but your cables only. Cables are nothing but those signals. You can imagine it is like this. Whatever the signals are going through your cables, this is what. Or sometimes your cables are analog like this. The signals are going like this. So whatever the cabling is, purely that is a physical layer. So that is the reason layer by layer, everything is defined and everything it has its own job. So now let's check how the packet will be formed. First of all, you are sending one hi. So hi will come here and I'm sending just hi on WhatsApp. So this is hi. So now I'm starting from layer 7. Layer 7 will be the starting layer for your sender side. Presentation layer, it would identify and it would check data is this. So altogether, I would say now this is layer 7. So totally, if I type hi, it is layer 7 only. So up to here, I have hi. Now, what will happen on transport layer? Transport layer, once the packet is handed over to transport, every layer's job is top layer will be processing the data and it will be handing over to the lower layer. Now, transport layer would take the control of hi and it will encapsulate this hi, for example, like this. It will turn it and now it will add something. It will add what? It will add the port number. So whatever the port number, for example, let's say my P1 is the source port and my P2 is the destination port. So it will add like this. But then I do have one, this, so far I have this packet with me. So I do have hi and now I do have, let's say up to layer 4, I have hi. And now apart from this, layer 4 header. Layer 4 header means source port, I would say source port and destination port. Now this is done, job is done from the layer 4. Now it will encapsulate it like this and it will hand over the data to layer 3. So now at layer 3, whatever the data you have received, this is the data you have received. So that is the data you have come across up to network layer. So now network layer would receive it and it would add its own header. So that is called, it will call it source IP and destination IP. So it will add these two things. So together now network layer is ready for its own packet. So that is the outcome of when the packet will be actually done with its own work over here. What about data link layer? Now data link layer would receive this all information and now it will add its own header. So it will add whatever the source MAC is and destination MAC is. How to calculate, how to get the destination MAC, we will cover in the packet flow. So, but overall idea is this is what your layer 2, up to layer 2, the whole packet has become. Now, when this whole chunk will be handed over to physical, nothing will happen. Simply everything will be turned into signals. Everything, every single thing, because everything, if you will see, it's a number only. Source MAC, destination, again number. Source IP, destination IP, again number. This is again number. And this high will be also turning into binary. So everything will be turning into binary. So everything will be into 0101 form. So it will be like a very long pattern because we are representing all these things all together. So this 0101 will be sending through the wire. Now what will happen in the receiver end? So receiver end, it will be starting from the layer number 1. So it will start, it will receive the wire of your PC first. PC means your internet wire will receive it. Now it will simply keep on removing. So at layer 2 of the receiver end, it will simply, first layer 2 will discard it. This is layer 2 is done. Now it will hand over the data to layer 3. So it will transfer the data from bottom to top. Now layer 3 has received it. Layer 3 will again do the same thing. It will remove it. Then now you have come to know what is the source and IP also. Now it will be the duty of transport layer. Now transport layer would identify whether this hi is meant for the WhatsApp, Insta or Snapchat, what. So that is the job of your transport. So it will be again chopping it off. So over here, chopping it off means identifying everything. Session layer means now it will check who has sent it, and I have a connection established with that person. You have a connection between these two client and or server, whatever the machines are, then only you are able to send something. Otherwise, if you don't have any session established, you can never ever send any data. So all together again, these 3 layers will be called one more time as layer 7 header. So ultimately, you will be receiving hi on WhatsApp. So everything will be, processed. So adding